Hi everyone, welcome to our next video lesson. This is chapter 5, lesson 1. We're talking about bisectors today. So I just want you to think about this one for a moment. Here's a conditional statement in if-then form. If a point is on the perpendicular bisector of a segment, what happens? So this right here is a perpendicular bisector. It's perpendicular because it's 90-degree angle, and it's a bisector because it cuts that segment in half. So if I have a point on the perpendicular bisector, what do we notice? I'm going to open up this sketchpad document here so you can maybe better see this. Point A is on the perpendicular bisector of segment CB. Notice the distance from A to C and from A to B. The distance from A to C is 6.76, and the distance from A to B is also 6.76. So those two lengths are congruent. And notice how I could switch around and make things different, but as long as A is on the perpendicular bisector, AC is always going to be congruent to AB. So what I want you to write down in your notes here is, if a point is on the perpendicular bisector of the segment, then it is equidistant from the endpoints of the segment. So equidistant, of course, means it's an equal distance. So this distance from the point on the perpendicular bisector to the endpoint is the same distance from the same point on the perpendicular bisector to the other endpoint. Those two distances are congruent. The converse class is also true. So the converse is, if a point is equidistant from the endpoints of the segment, then this point right here is on the perpendicular bisector. So that's what this next statement is going to be right here. Please write this down in your notes. If a point is equidistant from the endpoints, which this point is equidistant from the endpoints, so it's just the converse of the first one, then it is on the perpendicular bisector of the segment. So that's our first point of this perpendicular bisector lesson. The second point, let's take a look at this one. If a point is on an angle bisector, so this blue line right here, I guess it's a blue ray, it is an angle bisector. It cuts the angle in half. If we have a point on this line, let's say we have this point right there, what do we notice about that point? Again, let's take a look at this sketchpad document to get a better understanding of this. So right now, point A is on ray BA, and it cuts angle CBD in half. So it bisects the angle. Okay? So I want you to notice what the distance is here from point A to ray BC and from point A to ray BD. Take a look at this distance. Right now, from point A to ray BC, it's 4.61. The same thing from point A to BD is also 4.61. So we would say that AC is congruent to AD. Now again, I can move point A along this bisector any way I want to, and it's always going to make congruent segments. Okay? Again, I can also maybe change my angle around a little bit, but as you can see, as long as BA is a bisector, then if A is on that bisector, it's always going to be a congruent distance or equidistant away from both sides of the angle. And that's what this is going to say right here. If a point is on an angle bisector, which it is, then it's an equal distance from the sides of the angle. So from this side of the angle and this side of the angle, this point is an equal distance away. And then the last property is the converse. So once again, if this distance and this distance are equal, if that point is an equal distance from the sides of the angle, then it is on the angle bisector. This would cut the angle in half. And that's what this next property says. If a point is equidistant from the sides of the angle, then it is on the angle bisector. So those 4 properties, it's kind of 2 properties because one property has the converse and the other property also has the converse to be true. So knowing that, we could answer this question, and it looks kind of like a mess right now, but let's break it down. It's actually maybe simpler than it looks. Line L, M, and N are perpendicular bisectors of PQR. So here's line L, okay? It's a perpendicular bisector, so that means this is 90 degrees, and it cuts PR in half. Here is line N. It's also a perpendicular bisector, so this is 90 degrees, and it cuts QR in half. And then M is also a perpendicular bisector, so here's line M. So it's 90 degrees right there, and it cuts PQ in half. All right, so now that we understand this picture a little bit better, it now says they meet at T, so T is a point that is on all 3 of those bisectors. TQ is 2x, PT is 3y minus 1, and TR equals 8. Find x, y, and z. Well, let's go in that order. Let's find x first. So right here I see 2x. And 2x is the distance from Q to T. So let's just kind of break this down one step at a time here. QT is this length right here. And if T is on the perpendicular bisector for N, that means that QT is an equal distance away from TR. It's that first property that we talked about. If T is on the perpendicular bisector, then it's equidistant away from the 2 endpoints. Q is an endpoint, R is an endpoint, so they're equal distances away. So 2x is an equal distance away from 8. Well, now it's quite simple to solve for x, isn't it? Divide both sides by 2, so x equals 4. So we have found x. Now let's find y. And y is going to be a very similar situation where we know that from P to T is 3y minus 1. And T is on the perpendicular bisector of line L. So T would be an equal distance away from the endpoint P as it is from T to R. So TR is the equal distance as TP. They're congruent segments. So 3y minus 1 equals 8. They are equal distances away because T is on the perpendicular bisector. So we solve for y. 3y equals 9 when we add 1 to both sides. And then we divide both sides by 3. So y equals 3. So I got x to equal 4. I got y to equal 3. Last thing, we got to find z. Now z is right here. And L is a perpendicular bisector. So if L is a perpendicular bisector, this angle is 90 degrees, and it cuts PR in half. That's what a bisector does, is it cuts it in half. So that means that P to this point is congruent from R to this same point. So Z plus 4 is a congruent length to 7. Z plus 4 equals 7. So subtract 4 from both sides, Z equals 3. That concludes our video lesson on perpendicular bisectors. Let me know if you have any questions when you get to class tomorrow.